Okay, this is a quick follow-up on the failed TIPM from my last video. So I had suspected that this V-power connection on pin 2 may not actually be connected on the PCB to this main V-power input as is recommended in the data sheet. And the reason I suspected that was because we measure 2.2 ohms between the two connections, between this decoupling cap and the V-power plane here. So what I did was I took the chip off of this board I got from the junkyard here that we know the light outputs are working on. So I measured on the board, demonstrate right now. So between V-power, the plane on the bottom of the chip, and the decoupling cap. Can you guys see the meter? No. It's completely open. And you can see on the board that there's no connections under the chip. Okay, so here's the chip that was removed. So we're going to measure between that V-power connection and pin 2. We have 2.3 ohms. Okay. So, what I think we have here, so here's the block diagram. It shows one V-power input and then just this rail where it's all connected. What I think we have here, I don't know if you can see that very well. So I think we have the V-power input, so that's gonna be high current, that large pad that's gonna feed the output FETs. And then we have about 2 ohms of resistance between that and the pin 2 input, and then that goes all to this other low current circuitry here. We have a internal regulator, over voltage, under voltage protection. Now I just drew it as a resistor. I don't know what's exactly inside this chip, but there's some resistance between these two connections. So what they did, I drew a little picture of how they have the decoupling cap arranged here. So what they did is they did not connect these two on the board as the manufacturer recommends, although it doesn't give a great detail as to why. But then on top of that, what they did is they just hung a decoupling cap off of this pin 2 V-power input with no other connections to it. So first of all, it's not very effective for decoupling, since you effectively have your V-power input and then you have 2 ohms between that and the decoupling cap. So you have a voltage drop here, so it's not gonna filter out high frequency noise very well. And then also what you have is any ripple on the battery input now becomes power dissipation in the IC, because you have an impedance between that input and a decoupling cap. So I suspect that's what caused the IC on the board that we're looking at to fail. So we can tell a couple things now, and I'll demonstrate this. We know that we don't have a solder problem because, well, I'll demonstrate this. So we know we don't have a solder problem first off when we jump power here, everything starts working. So we know we have a connection there. And then let me show you the other reason why I know we don't have a solder issue. Make sure everything's hooked up right here. Alright, get the test light on here. This isn't shot, nope. Alright. And I went ahead and took out that solder bridge on this board so it doesn't work anymore. Okay, so V-Power is directly connected to the main battery input, so I'm just going to go off of that, and I'm going to do the milliamp range again for a jumper, but we're actually going to look at what we read here. So I have a milliamps DC. So let me go to the decoupling cap, and then we're going to go to the main battery input and get you a better shot. And you see it reads 4.37 milliamps. So clearly it's just powering up some internal circuitry. It's not powering the test light, which is out of shot again. Let me show you that again. See the test light lights, so we got 4.37 milliamps DC. So clearly it's not powering the test light, because if we just power the test light through the meter, good connection, it's about 250, 260 milliamps. So what do we know? We know that we have power going in this main V-Power pad here through the FET to the test light, because it's clearly not coming from pin 2 because it's not drawing enough current. And we know that the solder's good on pin 2 because we're jumping power to this connection and it's making the pin 2 and it's waking the thing up. Okay, I think that's it for this one. Thanks.